Great. So in this panel, we want to talk a little bit about what's been happening with the different data center specifications, both the NVMe and the SATA SAS. Is that still? Oh, let me get it. Let me get it. Like this. Let's hold it. So with that, my clicker not working? Oh, okay. So to start off, I'll kind of walk through what we've done, and then we're at the end, each of us is going to kind of walk through some of our hyperscaler perspectives, or enterprise and hyperscale, I should say. so, so for those people not in the know, the October version of the steering committee approved the version 2.6 update to the data center NVMe SSD specification. So it's going through the kind of quiet review period sort of thing. Anybody speak up or forever hold their peace sort of time. So it should be out on the website either later this week or early next week. And so with that, some of the things that we've added to that spec from the 2.5 to 2.6, we've expanded some of the error injection data that we like to see from the SSDs. Error injection, for those who don't know, is something that we use to allow from the host side, we can inject an error into the device. The device then runs through its error recovery for that error, and we exercise both the firmware and the host software in conjunction with that. And telemetry, we got lots of good feedback saying that the 16K that we said we wanted for the default size was too small for the telemetry, for all the new rich metadata that comes with the standardized telemetry. So we've expanded the first data area to 32K. So it gives you twice the space to figure out how you hung yourself. Another thing, we had to have some stuff around the requirement to have a watchdog timer. Everybody kind of implemented a different time period. So we decided to kind of come in, and it's fairly aggressive at 2 seconds, but this allows us, if the firmware is hung, the device can see this timeout, reboot itself, and we stay within the 10-second timeout of, say, of an IO. So we preserve that and don't have an issue with a reset. So another thing we have here is the stuff that we have with the error recovery that's been talked about today earlier. With that, we have kind of a rich set of actions that you could do to recover yourself in the SSD. But with that, a lot of those actions are actually impactful to a VM because we do some sort of reset underneath, which basically comes into what we call error, which is basically the annual incident rate for the VM. And so it's kind of SLA uptime. So we want to try and get to the point where pretty much anything inside the SD goes wrong. It's got enough smarts in it though that it kind of recovers itself underneath the covers and just kind of tells us something went wrong. And so, by the way, you should probably go look at the telemetry. Now that's, North Star, but that's the way we want to drive things. And the other big one here, so OCP came up with the SAFE. This is the security audit framework that was implemented back in the spring. With that, we want to push all the storage vendors on all the different firmwares to be able to go through that SAFE audit. Now, of course, this is a very heavy lift for the first round, okay, because that's the entire firmware needs to get covered. But in subsequent rounds of firmware, say for a maintenance release or that sort of thing, just the changes need to get covered. And so it becomes easier and easier over time. And so we're in H2 and we're released, so that's good. Now going on to the SATA SAS spec, or SATA, we interchangeable. So some of the things that we had a 1.0 spec, and it was out for over a year. And with that, because of all the great progress we've made in the NVMe spec, things like telemetry and sort of that, we're going to be taking all that kind of goodness that with that human readable telemetry, and we're going to port that over to ATA and to SCSI. So using vendor unique log pages and things like that. So we'll have all that analogous stuff with the HDDs and SSDs using SATA and SAS. Same thing with the TC configuration and history logs. These were added in 2.5. And we want to make sure that the stuff with that so that we can track kind of security audit functions. And we want to be able to do that across the board on all devices. Of course, security. Every time we update the NVMe spec, we add more security requirements. I think we're over 60 now or something like that. So a lot of that we need to kind of comb through and decide what we want to do to update the security section in the SATA spec as well. And this one, the release timing is also H2. That one, I'm going to be frank, we're a little bit tight on that one. We wanted to get it out in December. That's maybe a little bit of a stretch goal now, but we're certainly going to try. And with that, storage consumer panel. So I think, actually, I was going to have Ross do this one.
Wow, I get to read. I'm so excited. Okay, some general comments. So the device specifications for OCP we feel are valuable. You know, I encourage, there's the feedback CLA that we talked about in the morning with Mike, and that drives increased clarity on the requirements. So if you're interested in that, reach out to Mike Allison at Samsung. Maintaining SSD and HDDs at scale is a very major challenge for everybody here in the room. It's very difficult, maybe I should say. There's always stuff going on. Also, I wanted to note security is important. Customer data is valuable. You know, security improvements are needed. And we've been working very hard of how do we make improvements in that area. And with that,
back to me.
Back to Lee.
So kind of from our Azure perspective on some of the stuff, security. I can't stress that enough. Section 12 of the security section, you know, please go read through that very detailed. All the things that we're doing with Safe and now with Calyptra and Lock, super important. It's gonna, so I want to say this, recently, Satya came out and basically said security is our #1 initiative. And what we need to do is every single employee at Microsoft has a security KPI. So with that, I'm glad that I'm working on Lock because that's the security stuff, so that's great. But I think we need to all in this room, all of us, it's everybody in this room's responsibility. So. But then again, next on to that, debuggability, as Ross was saying about the importance of the telemetry. If we can take the current feedback loop where we really can't, you know, the debug data is kind of sparse and it's not human readable, we can't really get it out of the data center very well, and then that means that we got to kind of figure it out with the vendor, maybe we get another test firmware, that peels another layer of the onion, and that goes round and round. And so by the time we finally get something figured out, it could be up to months. And so we really need to get to a point where we can do that in days, if, you know, at the worst weeks, and hopefully in days. Resiliency, I kind of talked about this before. Increasing core counts and device sizes, that's, you know, you end up with bigger blast radius, and you have to figure out creative ways and different things to make sure that that doesn't happen. So especially in the sense of most of the stuff we see in the device is not hardware failures, it's not hardware glitches, it's firmware bugs. And so simple asserts in your firmware, they don't cut anymore. We have to get rid of those. You have to have error recovery either at some of the levels and even at best case, how can you structure things such that if you encounter that error, you can go back and kind of correct yourself, that sort of thing. And so out-of-band RAS is becoming super important as we move to bare metal systems where we don't really actually have a host for the VM. It's all VMs. Or even a client who takes over the machine entirely and has one run service on it. So with that, we have to be able to manage all of the features of the SSD, including firmware update and panic recovery and all that stuff out of band. So MCPP and all the different stuff from NVMe that we've been putting into the spec, super important. And with that, Dell.
Okay, so Dell view of this is telemetry is important, and not just for the debuggability reasons you've heard about. We're interested in streaming it. Periodic telemetry uploads for diagnosis and prediction at scale. Now, I should clarify here what I mean by streaming. I say streaming, people think video streaming. No, 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 no. The periodicity between uploads is going to be measured in hours, maybe a few times a day. We're interested in long-term behavior tracking for failure prediction, so we can figure out the drive is going to fail before the customer notices that something is wrong. When something does go wrong, automatic recovery is very important for all the reasons Lee described. We're looking for automatic recovery from common errors, failures, panics, et cetera, and report what happened. Oh, by the way, telemetry. See the first bullet in the slide. And finally, security. We have put a lot of work into refining and improving security. A lot of this comes from some experience in making TCG and SPDM work in practice. It's reflected in the new version of the spec, and we're very happy to bring it to you.
All right, so from HPE's perspective, security, again, not surprising, that's important to everyone, right? So one of the specifics, though, I wanted to touch on around security was accelerating the support for post-quantum cryptography. So that's something that CNSA is calling out, right? So we need that for digitally signed firmware. We're going to want, there was a talk earlier on SPDM and how we have support for the upcoming 1.4, which is going to support post-quantum cryptography as well. So that's coming next year from CNSA 2.0, and when I look at the industry, I don't see a lot of drives that are meeting that timeline. So I think that's something we really need to have accelerated, and in the latest release spec, we put in some additional language to try and make that more clear that this needs to happen starting next year. And we know that's a hardware requirement, so we need to figure out how we can get that done in the industry. NVMe sideband. So this is an interesting one because it's related to the PQC requirements, and so we did move to a requirement for I3C support in our latest revision of the 2.6 spec, and that's primarily to support these much larger PQC signature sizes that we're seeing coming. They're up to 500 times larger than the ECDSA P384 signature sizes, so I2C is not going to cut it for those large signature sizes anymore, so we really need to get that support. And something that's not on this slide, but something that we're looking at is, this is certainly kind of the short term we need to get to for I3C, but looking at moving to a universal sideband interface of USB is something we need to work on, and that is an industry for EDSFF we all need to work on because we don't have an easy way to get there on EDSFF today. And then sustainability, right? That's very important. We did add some new active power reporting capabilities in the latest version of the spec, so you can go check that out, like Smart 47, I think, and 48, unless our numbering changed, which is possible. But so that's good. So we need to be able to monitor how much power the SSDs are using at any given point in time, so we can understand that, and lifetime power. All of these things around sustainability are important. And we want to continue to get power efficiency innovations, right? We need to be able to have that 5-watt EU idle power without having an exit latency. So we need to make sure that you can continue to improve and innovate on the power efficiencies so that we don't have to do extraordinary things to meet those requirements. All right.
This is going to sound similar to what other people have said. Very high, at a very high level, right? Drives are just more complex. What Lee was saying, right? The iteration time and finding bugs and resolving them is not okay. We need to improve on debuggability. Right. And so the telemetry in the OCP spec is critical for that. The recoverability is important as well. On the security side, it's the other big bullet, right? User trust is paramount. This data is very valuable. The reputation of the hyperscalers on the line when we put user data on these drives, and I'm sure you guys have also harped on security as well, right? So, but I think one point to make is that an exploit on any SSD really comes across as a lack of trust in all SSDs, right? So Lee said earlier in an early talk, security needs to be boring, and it's a similar way, like we're all in the same boat when it comes to security, and we've just got to make it uninteresting, boring, and rock solid, and kind of everybody rises together in this, I think. So.
Great. So on the meta side, I think there are a bunch of improvements that create a lot of value at scale. Earlier today, we talked about FTP and all the benefits around that, whether it be wear, power, performance, QoS. The telemetry, you've heard everybody talk about it. I'm going to continue this message. You know, debug quickly, efficiently, predicting problems ahead of time, all super important. Latency monitor feeds into that of identifying problems quickly and being able to resolve them. Open source stuff, OCP, NVMe, CLI, having an open source CLI to control everything, super valuable. And open source qualification test cases. Once again, speeding time to market. And so these are all valuable things that we think make a big difference. So with that, I think we are to question and answer. So there's a mic here, and I see the first question coming here.
So, Paul, can you guys hear me? Okay, how's this?
Much better.
Hey,
That's good.
All right. You mentioned the I3C. Yesterday we had a speaker who was saying it's not going to be fast enough, we really need USB. How would you respond to that?
Well, that might have been me. Let me caveat that. I think as an industry, I3C is not fast enough for every single use case. And so the point I was making yesterday was that we're moving down this road of we need a faster sideband than I2C. And I3C is kind of the quickest thing we can get there. Everybody's been pushing that for a while already, so we know we're going to get there. But from an OCP, DCMHS platform perspective, when we look at plumbing I3C and USB to every single connector on the motherboard, that becomes extremely expensive. And if we don't really, so essentially it's like if we can get to one interface to rule them all, that's the good thing, right? So let's try and get there. I3C can't be that long term. It's not fast enough. But it is fast enough for PQC. And so if we can, say, okay, let's look at the long term is how do we get to USB as a single sideband interface. There's already a lot of work in DMTF to get, MCTP over USB going and everything else so that we'll have all of that kind of manageability capability there. But I think in the short term, we can do things like I mentioned yesterday where we could say, all right, SSDs may have I3C today. From an HPM perspective on the motherboard, if we want to interface to devices that only have USB, well, you could do that with an I3C to USB bridge chip. So even though the SoC may not have USB native, there are ways that we can get there so that from a motherboard perspective, when we're all doing that in OCP, we can really reduce quite a bit of cost and not have to put I3C and USB on every single MCIO connector, for instance.
Okay, thanks.
Yeah.
Sort of an adjacent question. So for Azure, Google, and Meta, they are the end user. They have perfect control of the operating environment that the drive goes into. The point being that some telemetry and these logs and latency histories and everything like that, you can access it in band. But for you guys, your end users can do whatever they want to for the operating environment. So I'm wondering how seriously you're taking sideband for accessing that predictive and monitoring information.
On a server platform, we're going to extract the telemetry via the BMC, which is running our code, and the properties of telemetry data area 1 are crucial. Because when we extract that telemetry, we do not want to disrupt the workload that the server is running to earn its keep for the customer. And so that's the answer, which is that we will come in via the BMC to get the telemetry, and that requires making arrangements with customers. And all of us know of customers where no data leaves their site under any circumstances, and in that case, the best we'll be able to do is perhaps collect telemetry on site that is specific to that customer.
Did that answer your question? If so, I'll just say ditto what David said. Okay.
I'm wondering because some of the security requirements, and as you were saying, the signatures are going to reduce the payload throughput and all that sort of stuff. So that's and there doesn't seem to be a big push on sideband in most of the stuff I've seen. It's all in-band. So I'm wondering if that's gonna take on some.
Yeah, so I guess you're asking more of the physical interface, the sideband, and how we're going to do that. It's clearly coming from the BMC. I think there are multiple ways we can do that over PCI VDM. That's not available everywhere in every root port, so that is problematic. It's also not isolated from the host OS, right? The host OS can do PCI resets, which then causes you to lose your sideband, because it's not truly a sideband, it's an out-of-band interface, but you lose access to that if you're the BMC. So it's not an ideal interface, but it's much higher bandwidth. So that's certainly in a day-to-day of saying getting telemetry, that could be a mechanism we would use is MCTP over PCI VDM. That's an alternative to I2C. Depending on how much bandwidth we need, then I think it's the same question with the PQC stuff. It's I2C or go to I3C, or then you go to PCI VDM to get that additional telemetry, especially if you're pulling a whole bunch of telemetry out.
And I would comment that the signatures are mostly about firmware images. It's not about routine, this kind of routine extraction and management.
Yeah, I was just going to add that, like Lee mentioned before, there's getting to be more common these machine instances, like the whole machine gets shared with an end customer. So your statement that we have perfect control and can run everything in band is not true in those cases. And so we also are looking at BMC out of band for telemetry because of that. And since it's the lowest common denominator, why not just do it everywhere instead of managing two telemetry stacks, right? So.
One more comment before we go to the next question. This is a good question, by the way. Is I did want to note that OCP NVMe CLI is up on GitHub, runs under Linux, and anybody can pull that down and use it to pull the telemetry information. And that is updated in there today. With that, we have a question over here.
Are you suggesting that the drives are going to be, the NVMe drives are going to be changing from an I2C interface to an I3C interface and then to a USB interface over the next couple of generations, which means you don't really get back compatibility from various PCIe generations?
Yeah, what's wrong with that?
Cost is no object. It's great.
Yeah, yeah. I mean, clearly, right. There's always how do you actually really do that? But I think that we've been pushing I3C for a long time, so that's not a new requirement. We did, in the latest OCP spec, we did make it a, it is now a new requirement, but we've been talking about it for a long time with vendors. I think they knew it was coming. So I think I3C being there on drives, EDSFF really standardized that. So if you look at the drive industry and say, we came up with that, we donated it to PCI SIG on how you negotiate between I2C and I3C. So that's not surprising. I think what we're seeing is to say, can we get to one interface and making that USB? That's kind of the new thing. And so that might be a little bit longer term. But I think, like I mentioned with I3C to USB bridges, that might be a short-term way to do it and still provide that functionality so you don't have to pay the tax on the motherboard for all of these different components that aren't necessarily needed.
Still have to route more high-speed signals and on it. So we're talking the same pins. We're not talking multiple interfaces on a physical drive.
Yeah, so I2C and I3C are the same pins, right? You just negotiate up from I2C to I3C. USB won't be. We'll probably have to change, just like PCI Chem, right? They have dedicated pins for USB and dedicated pins. MXIO, the pin out for OCP, same thing. There's dedicated pins for I2C, I3C, and then different dedicated pins for USB.
My just concern is there's not 32 chem cards in most platforms, and we're moving in that direction.
Yeah, and we want to make sure that, right, and the SI of USB is pretty easy. That's another reason why we are recommending that, is that's a much easier interface to route all over. Yeah.
So systems designed with sorry, I'll stop here. But USB systems that get designed for USB you can't put a previous generation of drives in those because those would need I3C or I2C.
Well, no, yeah, I mean, you'd have to have some transition period where you're going to say, we've got to have some routing for I2C, I3C on some MXIO connectors, and at some point, if we get to where we have USB everywhere, we can, but if you don't make that requirement here, you'll never get there.
Yeah, but
Yeah.
running more management buses is not.
Yeah, and let's be clear about timeframes here. As Paul said, we've been talking about I3C for quite some time. It is the next step that is coming on SSDs. And we are at the correspondingly early stages of discussion of USB. Stay tuned to watch how that one plays out. It took us a while to make the move from I2C to I3C. The next move is not coming right away.
Okay,
Thanks.
Dan.
We're going off the deep end on sidebands.
Sure, we're engineers. We love rat holes.
It sounded like even all of you kind of were echoing it. Even Chris was saying it sounds like the path to USB is more real than the path to just get rid of any other wiring and go with PCIe VDM. Is that echoed through? Was that a true interpretation? Why bother with USB if we already have one connection?
I think Paul got a lot of it, which is that PCI VDM fate shares with the PCI infrastructure, and we do not want a dead root port taking out our ability to figure out what on earth the SSD is up to.
We really want an isolated control plane, and that doesn't give us an isolated control plane at the end of the day.
I don't know much more to say on that.
More questions? Okay. Okay, then it's break time, and we come back at, what time do we come back at? Before I get myself in trouble, give you guys the wrong time. 3:30. 3:30 start up again. So you have a nice break, and we look forward to seeing you back.
Hour break for that.
And thank you very much.
Thank you.